In this video, we're going to be continuing the upgrade of this dual 867MHz PowerMac G4 MDD CPU card. Now, in the last video I made on this board, we took the original MC7455 CPUs, the 867MHz ones, and swapped them out with two 1.267GHz rated MC7457 CPUs. Now, in that last video, I was hoping to get the CPU clock speed up to around 1.6 GHz or so. However, due to limitations with the L3 cache on this board, that was not possible. Now with that said, in this video, we are going to address that issue by upgrading the L3 cache chips to a 2 MB per CPU instead of just 1 MB like this card has on it now, but we're going to be taking the 250 MHz rated chips. Let's see if I can get this in a better light here so you can actually read them. There we go. As you can see, these end in HC25 in the part number, which indicates that they are 250 MHz chips. Now we're going to be upgrading these with 1 MB chips. There are 2 chips per CPU, and the new chips I'm going to use are rated for 300 MHz. Now, not only that, we are also going to be reflashing the Spd Eeprom on this card, which is located on the back right here, to firmware from a 1.42 GHz CPU card, which actually runs its L3 cache at a lower ratio, or higher ratio, however you want to put it. I believe this card runs it at like 5:1, whereas or 4:1 or 5:1, I forget the exact value, whereas the 1.42 GHz cards actually run their L2 cache at 1:7 ratio, so, or a 7:1 ratio rather. So these chips right here on this donor CPU card are what we're going to be using. As you can see, they begin with K7D8 in the part number, whereas these begin with K7D4. And that indicates the size of the chips. These are, like I said, 512K a piece, whereas these chips on this donor card are 1 MB a piece, so we'll be able to achieve 2 MB per CPU. Now, also on these new chips, you can see they're rated HC30, which, as I mentioned, means 300 MHz. So these will be a perfect donor for our target CPU card. Now, I have to give a thanks to the guy who actually sent me these cards. They are in bad shape. They're not actually repairable, so they're good for parts. But I do want to thank Greg Rutke of Rutke Mods for sending these cards in to me. He sent these in to me for parts, and that's exactly what they're going to be used for. So as you can see, the PLL resistors here are not looking too good, and the voltage regulator section over here is not looking too good either. But like I said, for parts, they are perfect. So what we're going to be doing in this video is I'm going to be desoldering all 4 of these chips, the 1 MB chips as I mentioned. There are 2 on either side, 2 per CPU of course. We're going to be reballing those chips, then desoldering the chips on this board, and soldering these chips after they've been reballed onto this board. And then once we do that, we're going to flash that Spd Eeprom as I mentioned, and see how fast we can get these CPUs to run. With all these upgrades done, I hope to get them up to 1.6 GHz as I originally intended. And then with the extra megabyte of L2 cache per CPU, we should have a nice fast system. So with that, I'm going to go ahead and get my camera mounted in the tripod here, get this board prepared and ready to desolder all 4 L3 cache chips, and then we'll begin the process of reballing the chips. So I will resume the video. Alright, so as you can see here, I've gotten the board ready to begin desoldering the donor chips. So of course the first step is just to apply some flux to them. So I'm just going to go through and just do one at a time, obviously. So this should be pretty quick, and I'm not going to use the big board preheater because this little one is just enough to get right underneath the CPU and will work just fine. So I've got my hot air set to around 280 degrees Celsius, and I've got this preheater set basically as high as it'll go, because there's a decent amount of distance between it and the board itself. So I'm going to go ahead and begin desoldering the L3 cache chip, and we'll just go around and desolder all 4 of them. Alright, so as you can see, we have successfully removed one of the chips, and I did end up turning the hot air up a little bit to around 327 degrees, and that was enough to get it off, no issue. So now we're going to go ahead and move on to the second one right next to it, and just continue with the same process. Alright, so as you can see, we have gotten all 4 L3 cache chips off of the board. So now we just need to begin preparing them to be reballed. So I'm going to go ahead and get all that set up, and then I'll go ahead and resume the video. Alright, so as you can see, I've gotten all the chips prepared and ready to begin cleaning them. So of course the first step is just to desolder or remove all of the residual solder that is on the chips. So that's exactly what I'm going to do now. Just add a little bit more flux to that one. And then once you've gotten most of the big pieces off, you can just go around with the solder wick and get everything else. Just like so. So I'm going to go ahead and just repeat that same process for the other 3, and then we'll be ready to begin reballing. Alright, so now that we've gotten all the residual solder removed from the chips, the next thing we need to do is just clean them all off with some rubbing alcohol, make sure there's no old flux still on them, and then we can begin the process of reballing the chips. So I'm going to go ahead and pause the video here, get these all cleaned, see if I can find a suitable stencil for these chips, and then begin the process of reballing them. Alright, so as you can see, I've gotten all the chips ready to be reballed, and I actually managed to find this really big stencil that I can just set on all 4 of them at once and just reball them all at once like that, as you can see. So the only annoying part about this is you kind of have to get them all lined up pretty well, perfectly, but I managed to do that no problem, and we can go ahead and just reball all of them at once, which saves a lot of time. So I'm going to go ahead and prepare these chips to be reballed. So the first step in doing that is just applying a little bit of flux to each one. And then just heating them to melt that flux, and then rubbing it around on the chips just with a clean paper towel. So I'm going to go ahead and get the hot air warming up and do that real quick. Alright, so I've gotten the amount of flux on there that I want, so now we're going to go ahead and attach the stencil. So I'm just going to be using some Kapton tape to do that. And hopefully that'll be good enough. Alright, so they're not going to be perfectly aligned with 4 individual chips like that, but they should be good enough to solder no problem. So now I just need to get the solder balls ready and begin to apply them to the chip, or the chips rather. Alright, and that appears to be all the chips, or all the balls aligned with the holes on the chips, or the holes, or the pads on the chips rather. As you can see, there are a few extras in there. Those aren't going to hurt anything. They'll just melt and not stick to any pads. Actually, I see one that I missed here. Put that in there. Here we go. Now they're all filled. So now we just have to heat and until they start to melt. Alright, so as you can see, all the balls have melted as they should do. So now what we're going to do is just apply a little bit of extra flux once they cool down a little bit and heat them up one more time. And this will just get them all to fully seat down onto the correct pads. Alrighty, so now as you can see, it looks like all of the balls have fully seated onto their pads. So now we're just going to go ahead and let it cool down a little bit one more time, and then remove the stencil. Okay. Alright, so as you can see here, we do have a little bit of a mess to deal with here. So you want to just get all these extra balls off of the chips here. And that's just because of all the extra holes in that stencil. It's not going to hurt anything, of course. Let me try to get that in better focus here. I'm not sure what its problem is there. Alright, I think that's as good as it's going to get. So now what we're going to go ahead and do is just heat the chips up one more time, just to fully seat all the balls without the stencil in place. Alright, so now that all of the L3 cache chips have been reballed successfully, now we just need to go get the desired board, or the 867 megahertz board, and solder all these chips onto it. So I'm going to go ahead and get that ready, and then resume the video. Alright, so as you can see, I've gotten the target CPU card ready to go here. We've gotten the chips that we just reballed right over here. So now what we're going to do is I'm just going to go ahead and desolder all 4 of the chips from this card, and then just solder these in place. So I'm going to go ahead and get started on that now. Alright, so before I flip the card over, I'm going to go ahead and just clean these up and solder the new chips on just this side. That way I don't have to flip the board over 3 times or 4 times. So I'm going to go ahead and just get all this cleaned up. The process is basically going to be exactly like it was with the chips themselves, and then we'll be able to solder the new chips on. Alright, so as you can see, I've gotten all the pads cleaned and ready for the new chip to be applied. So in order to do that, we're going to start with some fresh flux. Just like so. And take a paper towel and just wipe a little bit of that fresh flux off. We just want a very thin layer on the pads. And then we're just going to go ahead and take 2 of our new chips and solder them on. There's 1. And there's 2. So of course now we need to ensure that the alignment of these is pretty much perfect. So in order to do that, just kind of look at them and line it up with the silk screen. Alright, that one looks good. And that one looks good. So let's go ahead and just take the hot air and solder them on. Alright, and that one looks to be soldered on successfully, so we'll go ahead and do the same thing for this one. Alright, so it looks like both of those have been soldered on successfully, so I'm going to go ahead and turn the board preheater off, let the board cool down just a little bit, and then we'll go ahead and flip it over and do the same with the other side. Alright, so as you can see, we've gotten the board flipped over, so now we can just begin the process of desoldering the chips on this side. Alrighty, so there we go. All 4 chips have been soldered on successfully. So now what we need to do is just let the board cool down, and then the last step before we start overclocking it some more is to flash that Spd Eeprom. So I'm going to go ahead and pause the video here, let this board cool down, and then we'll begin the process of flashing that Spd Eeprom. Alright, so I've gotten the card all cooled down and ready to go. So now we need to flash that Spd Eeprom. Now I actually already removed the Eeprom actually before I even started making this video because I was actually testing something from my previous video to see if I could just lower the ratio and get a little bit more clock out of it, but unfortunately that did not work. So yeah, I've got the chip right here, and I'm just going to go ahead and solder it on this adapter, which I can then use in my Eeprom programmer. So I'm going to go ahead and get that chip soldered. It's a pretty quick and easy process, and then we can begin the process of flashing it. Alright, so the Eeprom has now been soldered in successfully. So now what I'm going to go ahead and do is get my Eeprom programmer ready and show you exactly what we're going to be doing to flash the chip. Alright, so as you can see here, I've gotten the Spd Eeprom on its adapter inserted into my Eeprom programmer here. And I've gone ahead and opened the Eeprom programmer software. Now the chip I'm using is just a 24A CO2 serial Eeprom. So that's all that is. There's no real specific chip model for this kind of chip. It's just a serial Eeprom. So I'm going to go ahead and just read the original ROM here. And keep in mind this was from the original 867 megahertz card. So as you can see, it's read fairly quickly. It's just a 256 byte Eeprom. So as you can see, that's all the data it has in it right there. So I'm going to go ahead and save that just to a backup here. So we can do 867 megahertz, 1 MB. So that was the original 1 megabyte of L2 cache from my original CPU card. So now what we're going to go ahead and do is load this dump, which I've obtained from this user on the 68K MLA forums, who actually was kind enough to dump it and post it right here. So I'm going to go ahead and use that to flash my card. We'll go ahead and open it right here. And as you can see, the data was loaded. So now we're just going to simply hit program up here and program. So as you can see, the programming was successful. So we are now ready to use this Eeprom on my CPU card. So with that, I'm going to go ahead and pause the video here, desolder that Eeprom off that adapter, and solder it onto the CPU card. So I'm going to go ahead and do that, and then resume the video. Alright, so as you can see, I've gotten the card ready to begin soldering. So as you can see, I do have an Spd Eeprom on here already, but that was actually, I just took from one of those donor cards, specifically the one with 1 megabyte of L3 cache, just so I could see if that would help me overclock the CPU at all, but it unfortunately did not with those 250 megahertz rated chips. But now with the upgraded 2 megabytes of L3 cache rated for 300 megahertz, we should be able to get some decent clocks out of it. And I figure one thing I should mention about the Spd Eeprom that I don't know if I mentioned earlier is it actually is what stores the information that tells the system what the ratio is and what the size of the L2 cache chips are. So that is all stored in that Eeprom, that dump that I just flashed on. So once we solder that on, that will tell the system that it's got 200 megahertz or 2 megabytes of L3 cache installed and run at 7:1 clock ratio. So with that, let's go ahead and begin desoldering the chip. Alright, so as you can see, I've gotten the newly flashed chip installed. So now what I'm going to go ahead and do is just put the board in as is without changing any of the clocks. So that way we can just see if the board has will register the 2 megabytes of L2 cache that are now installed. So with that, I'm going to go ahead and pause the video here, get the card installed into the system, and we'll go ahead and give it a test. Alright, as you can see, I've gotten the CPU card installed, I've gotten the CPU heatsink reinstalled, along with some fresh thermal paste, so now we can go ahead and turn it on and see if it works. So let's go ahead and power it on. And it chimes, so far so good. Let's go ahead and see if we get a display. And we do. Let's go ahead and let it boot up here, and we'll see how much L3 cache is detected. And look at that. We've got the dual 1.25 config as we had last time, but now you can see it says we have 2 megabytes of L3 cache per processor. So let's go ahead into the system, or the system profiler here. And yep, as you can see, L3 cache per CPU is detected at 2 megabytes. So that upgrade was successful. So now what we're gonna go ahead and do is take the card back out again and set the PLL configuration resistors to get this thing clocked at around 1.6 gigahertz. So with that, I'm going to go ahead and pause the video once again, remove the CPU card, and set those PLL resistors. Alright, so as you can see here, I've gotten the CPU card up on the board preheater once again. So now what we're going to go ahead and do is change the PLL configuration resistors. Now, as I did in that last video, there are 2 sets of resistors that have to be changed, one per CPU, of course. So we're going to start off with attempting to get it running at 1.66 gigahertz. Now, that is probably a bit of a stretch for these CPUs. Of course, they are rated at 1.267 gigahertz. So it is quite a big jump for them. But we're going to go ahead and try it and just see if we have any luck. So I'm going to go ahead and set the resistors appropriately. So on this side of the board, the resistors are located right here. And I'm going to go ahead and start by applying flux. And to set it to 1.66 gigahertz, all we have to do is set R4 and R8 and deset all the rest of the resistors. So let me go ahead and get started. Alright, so as you can see there, I have now set R8 and R4. You can see R8 is right here, R4 is right there, and I have deset the others just by moving the resistor off of the second pad. So that one's not connected to anything on that side, and neither is that one. So we have R8 and R4 set right there. So now we need to flip the board over and set the resistors on the other side. Alright, so the resistors on this side of the board are located right here, and on this side, all we need to do is set R3 and R7 and deset all the others. So we'll go ahead and do that. Alright, so as you can see, I've done pretty much the same thing here. I just took R1 and moved it off one of the pads, and I took R9 and moved it off one of its pads. So now the only ones we have set are R3 and R7, which should give us the 1.66 gigahertz target. So I'm going to go ahead and let this board cool down. We'll reinstall it into the system and test it and see how it runs, if it runs at all, of course. So I'm going to go ahead and get that installed and bring you back when we test the machine. Alright, so as you can see, I've gotten the CPU installed one more time, so let's go ahead and power it on and see how it works. Okay, so far so good. And if you see this happen by itself, that means it is not happy. So it's definitely running a little too fast. Either that or the CPU Vcore voltage might just need to be increased a little bit, which I might actually try first. That's probably what I'll do next. So what I'll do is I'll just try to increase the CPU Vcore voltage. I believe I have it set to 1.3 right now, which is right in the middle of the operating range of the MC7457. But I'll try to up it to 1.4 volts instead, and see if we have any better luck then. So I'm going to go ahead and remove the card one more time and set that CPU Vcore voltage. Alright, so I've gone ahead and opened up the data sheet for the 7457 so we can take a look at what its recommended specifications are. And as you can see here, the core supply voltage recommended value is 1.3 volts, which is what we have it set to now. But since we're going to overclock it quite a bit, we need to see what its absolute maximum ratings are. So here we go. These are the maximum values right here, and as you can see, the 7457 can actually support up to 1.6 volts for CPU Vcore. So I think 1.4 volts shouldn't be much of a problem. So I'm going to go ahead and get the voltage set to 1.4 volts, and we'll go from there. I don't want to go too high with it. I will go up to 1.5 at the very most and see how that works if this doesn't work. But I would prefer to stay under 1.45 or 1.5 or so. So we'll set it to 1.4, see how it works, and then we'll go from there. So I'll go ahead and get the camera back in the tripod and show you how to set CPU Vcore. Alright, so as you can see, I've gotten the board back in the tripod here. So in order to set CPU Vcore, and I actually went over this in the previous video if you haven't watched that yet, but there's just a few resistors around this chip here, which is the voltage regulator for CPU Vcore. So there's a few resistors around here you have to change, and to do this I'm once again following the guide from J. Vry, or the House of Moth. I will link that webpage in the video description if you want to follow along for yourself. And there is also information about the CPU PLL configuration resistors on there as well, which I've been following for that. So I'm going to go ahead and get this set for 1.4 volts. So in order to do that, I just have to set a second resistor on here. So I've got this resistor set, this one unset, this one unset, this one unset, and this one unset currently, as you can see. So I just need to set this one, and that should give me 1.4 volts instead of 1.3 volts. Alright, so as you can see, I've gotten that resistor set now. Go ahead and let the board cool down once again and try it one more time. Alrighty, so after quite a bit of trial and error, I have determined that the best combination is 1.5 gigahertz at 1.35 volts. Now, unfortunately, that's not exactly where I was hoping to get, but hey, these are 1.2 gigahertz rated chips, so you can't really expect too much out of them. But they did very well overclocking to 1.5 gigahertz, like I said, with the Vcore voltage at 1.3 volts. And yes, I did try both 1.4 and 1.5 volts with it running at 1.66 gigahertz, and it still did not work as intended. So unfortunately, the best I could do was 1.5. I did try 1.58 as well. That didn't work very well. So I settled with 1.5 with the CPUs at 1.35 volts. So with that, let's go ahead and power the machine on, and we'll perform some tests. Alright, so as you can see, we have successfully booted. Let's go ahead and check about this Mac. As you can see there, we have dual 1.5 GHz PowerPC G4 processors with 2 megabytes of L3 cache. Let's go ahead and check here again. So yes, everything is detected properly there. So with that, we can go ahead and run Geekbench. Now I do want to open the original 7457 file that I did last time when I first upgraded these CPUs with the original L3 cache, and we can go ahead and take a look at the results. We will of course compare the results after I run it with the current upgrade done, but as you can see here, we originally had a CPU frequency of 1.25 gigahertz. That's as fast as we could go with that original L3 cache. So let me go ahead and just close out of this, and we'll go ahead and run the Geekbench. So I'm going to go ahead and pause the video here and resume it once the Geekbench has completed. Alright, so as you can see here, the Geekbench was completed successfully, and we achieved a result of 1268. So let's go ahead and open that original score that we got with the old L2 cache and running at 1.25 gigahertz. And as you can see, there is a decent improvement. So let's go ahead and scroll down here a little bit, see what our scores were here. You can see we've gotten much higher on the integer score here. Let's go ahead and check here. Definitely decently higher there. Memory even was a little bit higher as well, which is surprising. Stream was a slight bit higher, and that's all the results. So go ahead to the top and just compare the specifications again. As you can see, L3 cache here is now at 2 megabytes, whereas before it was at 1, and we were at 1.25 instead of 1.5 gigahertz. So that has been the successful upgrade of this machine, first from 7455 CPUs running at 867 megahertz to dual 7457 CPUs running at 1.25 gigahertz, and now we're able to upgrade the L3 cache from 1 megabyte to 2 megabytes and increase the CPU clock speed once again to 1.5 gigahertz. So with that, I hope you enjoyed this video.